Right, greetings guys, I hope you are good. We are talking about the number series. All right, we're talking about the number series, and it looks like a tough concept, but it is not if you understand what it is about. Well, we want to first ask, what is a number series? Okay, a number series is the sum of any given sequence, right? That's what a number series is. Let's take an example. Let's say you want to write the following sequence as a number series. Let's say you have 1, 2, 3, 4, and 5, and they say this is in sequence form, guys. That is in sequence form. What would be the series form of this? The series form of this would be simply 1 plus 2 plus 3 plus 4 plus 5. That is series. The difference is I no longer have commas. Instead of commas, I have plus. Okay, let me give you another one just to make sure you understand. 5, 2, minus 1, and minus 4. Who can tell me what form is that? That is sequence form. Okay, that is in sequence form. How do I know that? There are semicolons in between. How will I write it in? Series form? Simple. You know, this is 5 plus 2 minus 1 minus 4, which also can be the same as 5 plus 2 minus 1 minus 4. All right, so that is just the idea. With sequence form, you are having semicolons, whereas with series form, you are having addition symbols in between. But let's get more technical with it. We will use Sn to denote the sum of the first n terms. I should note at this point that we are dealing with finite series here. Ne? So we'll use Sn to denote the sum of the first n terms. Okay, now let's take this example. We want to take this example, and now we want to write it in with the new notation. Okay, remember we are using Sn to denote. Okay, what does n stands for? N stands for the number of terms, whereas this stands for the sum. Okay, guys, a sum must always be equal to something. All right, a sum must always be equal to something. All right, so let's check this out. This one here can be written as, how many terms are here? 1, 2, 3, 4, 5. So there are 5 terms. So this is S5 is equals to 1 plus 2 plus 3 plus 4 plus 5. Okay, and then of course 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 5 is 15. So the sum of the first 5 terms of this is what? Is 15. If I wanted to denote this, okay, using Sn, simple stuff, I would just say Sn, S for sum. How many terms are here? 1, 2, 3, 4. S4 equals to 5 plus 2 minus 1 minus 4. Do you see how simple that is? Okay, 5 plus 2 is 7. 7 minus 1 is 6. And then, of course, 7 minus 4 is what, guys? It is 2. So this is now the new symbol that we will use. We will say Sn. This S stands for sum, and N stands for the number of terms. All right, so now we are having a more mathematical format that we will use to represent our sums. Okay, this is the general form of the sum of the first n terms. All right, this is the general form. So normally you will have S1 being equals to T1, because what are you going to add the first term to? Let's go back to our example. So here, if they said calculate the sum of the first term, as the first term will just be equals to 1, because you're not adding it to something else. All right, but S2, that is a different scenario there, guys. S2 is equals to what? T1 plus T2. So the sum of the first two terms, it is the first term plus the second term. So in this case, if I wanted to calculate the sum of the first two terms, I would take this. I would say 1 plus 2, so that I get that it is 3. So the sum of the first two terms will be equals to the first term plus the second term. The sum of the first three terms will be the first term plus the second term plus the third term. Same thing here. If I wanted to find the sum of the first three terms, I would just say 1 plus 2 plus 3, which is equals to 6. Are you getting what I'm saying, guys? All right, the sum of the first four terms will be the first term plus the second term plus the second term plus the third term plus the fourth term. Very important for you to note that. So this shows to you that if I have n terms, generally I will have T1 plus T2 plus T3 all the way until where my terms end. All right, so you will add every term there and you will get the sum of those terms. Are you getting what I'm saying to you? All right, so but we can take it deeper here as we observe here. I want you to see something from what I did here, and I know it's a bit messy, but I want you to see something here. I want you to see that this one here carried over. So it would not be incorrect for me to write this as S2 equals to 1 is the same as what? Is the same as S1 plus 2. That would not be incorrect. Are you seeing what I'm saying? Let's check here. If you check here, you are having S1 plus S2 is equals to 3. Okay, and here we find 1 plus 2 again. There is 1 plus 2. This is equals to what? Is equals to 2. Are you with me? So this is equals to S3, which is equals to S2 plus 3. And we can generalize that. So in general, this is the situation that we are noticing here. We are noticing here that this here is that, meaning S2 can be written as S2 equals to T1, is equals to S1 plus T2. The same holds here. T1 plus T2 is actually S2. All right, so this can be written as S3 equals to S2 plus the additional term, which is T3. The same would hold here, that you are having this situation. S4 is equals to S3 plus T4. So generally this is what you would have. Sn would be equals to the previous sum, okay, the previous sum plus the following term. All right, if you look at this technically, okay, and I'm going to show you from the example that we have been working. If this is true, that this is S2, which equals to S1 plus T2, it suffices to say that if I know S2 and I know S1, I can actually be able to calculate the second term. Okay, the second term can be calculated by saying T2 equals to S2 minus S1. Well, guys, have you found, supposing that we didn't know what is our second term, do we know what is our second, do we know what is the sum of the first two terms? Yes, is 3. Do we know what is the sum of the first term? Yes, is 1. So the answer is what? T2. And lo and behold, our second term is what? Is 2. The same would hold here. If I know S3 and I know S2, I can be able to calculate what, guys? T3, by simply saying that T3 equals to S3 minus S2. Well, what is S3? S3, it's 6. What is S2? Well, S2, we just found it to be, here it is 3. So this is 6 minus 3, which is 3. And lo and behold, that is that. So this is what we are seeing from this. This is actually implying that if I want to find the second term, if I know the previous consecutive terms, I can be able to find any term. So for example, in this case, if I want to find the second term, I must simply say the sum of the first two terms minus the first term. Here, if I want to find the third term, I must say the sum of the first three terms minus the second term. Here, if I want to say, if I want to calculate the fourth term, same thing. I will say the sum of the first four terms minus the third term. So in general, what you are seeing here, guys, is that if you want to calculate any term in a given sequence, we must know consecutive the two consecutive sums. Okay, so I must say the next sum minus the previous sum, and this is going to be a very significant formula for you to know. Perhaps we can take an example if time is still on my side, and I will take this example. Take this as example 1. I hope I'm not gonna get too messy. Example 1, I will say consider the series, and I'm giving you 1 plus 4 plus 7 plus 10 and ... and I say to you determine S3, and I will also say to you determine S7. This statement says determine the sum of the first three terms. The second one says determine the sum of the first 7 terms. Okay, so let's try to do that. Right, let's try to do that. The sum of the first 3 terms, it means I must add 1 plus 4 plus 7. So the sum of the first 3 terms will be 1 plus 4 plus 7, which if you see that is 1 plus 4, it's 5, and 5 plus 7 is what, guys? Is 12. Very easy. If you want to calculate this, if you want to calculate the sum of the first 7 terms, very important here, you must generate this sequence even further, because this sequence, we are having how many terms so far? We are having 1, 2, 3, 4. We are having 4 terms. So let us first determine or ascertain what type of sequence are we dealing with here. Well, for me to go from here to here, I must add 3. For me to go from here to here, I must add 3. For me to go from here to here, I must add 3, meaning this series is arithmetic. So for me, so I must add to 10, I must add what? I must add 3 to get 13. I must add 3 to 13 to get 16. I must add 3 to 16 to get 19. Let's see how many terms are we having now. 1, 2, 3, 4, 5, 6, 7. So meaning if they are saying the sum of the first 7 terms, but let's say they gave you 3 terms, first thing that you must do, guys, is that you must ascertain what type of series is it that you are dealing with. Is it arithmetic? Is it geometric? Or sometimes is it quadratic? Because if you know what type of series that you are dealing with, you can be able to generate more terms in that series, because a sequence is the same as a series. It's just that with one you are having plus and the other you are having semicolons. Okay, so now we can now calculate that. So the sum of the first 7 terms would be 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19, which will give us 70. All right, I hope that makes sense to you. Let us go to example 2. I hope I'm still doing well with time. Let's go to example 2. We will then say determine the sum of the first 7 terms of the series with tk equals to 5k minus 3. Now I want you to check this example here. They have given you a general formula and they are asking you to find S7. So meaning first I must establish which terms are the first terms of are the first 7 terms of this particular series. Okay, so let's see. Using just the general formula, I can just substitute T1 there, and I say, okay, wherever I see K, I put 1, so that is that, and we get 2. Okay, for the first term is 2. And T2, that is wherever I see K, I put 3, so that is 7. And then I will say T3, wherever I see K, I put 3, and that is 12. Okay, T4, because I'm looking for the sum of the first 7 terms now. T4, wherever I see K, I put 3, so that is 17. And of course T5, that is 5. Wherever I see K, I put 5, and that's why we get 22. T6, wherever I see K, I put 6, that's why we get 27. T7, wherever I see K, I put 7, and that's why we get 32. Now we are ready to answer the question, the sum of the first 7 terms. Okay, if you want to calculate the sum of the first 7 terms, it will of course be T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7, and this is 2 plus 7 plus 7 plus 12 plus 17 plus 22 plus 27, and of course plus 32, which will give us 119. All 3, then we are ready for the arithmetic series, which I will introduce after this video. I will say to you the sum of the first n terms of a sequence is Sn equals to 3n squared. This is quadratic actually, plus 2n plus 1, and we will say to you determine the following: determine the sum of the first 8 terms, determine the sum of the first 7 terms, and of course determine the 8th term. Okay, all right, so let us go into it. So the first thing that we must do, they're saying the sum of the first 8 terms. We must in this case we are not given a general term. In this scenario we were given a general formula for those terms, so that's why we had to generate those terms. But in this case we are given the general sum formula. All right, the general sum formula, which implies that we can just use this formula to just know what is S8 and know what is S7. In the previous scenario they gave you Tn, so you use Tn to find Sn. In this case they gave us the general Sn, so we don't need to calculate terms here. We just substitute. So wherever I see n, I put 8 because I'm given Sn, I'm not given Tn. That is the difference. So this is 3. Wherever I see 8, I put wherever I see n, I put 8. Wherever I see n, I put 8, and you'll find out that your answer is 209. If they gave you Tn, then you'd first have to find 8 terms, then add those terms, then you'd have S8. But this time they gave us Sn. That's why we just substituted into the beautiful formula. Okay, then we are going to S7. All right, S7. Wherever we see n, we put 7, and of course our answer is 162. Then we want to calculate S8. Very critical here. You remember the formula? Well, some of you already know that. Okay, you remember the formula Tn equals to Sn minus 1. Okay, well, from logic you know that in essence we must just say T8 equals to S8 minus S7. Okay, there the next minus the previous. But if you forgot, you might as well cram this. Wherever you see n, you put 8. Wherever you see n, you put 8. You put 8. So this is 8 minus 1, and this is S8. That is S8 minus S7. Okay, have you found S8, guys? Yes, S8 is 209. Have you found S7? Yes, S7 is 162. So that means what, guys? Therefore, it means that T8 equals to what? Is equals to 47. I had to be fast with that video, but please replay it if that